Hello guys, welcome back to my channel. So today we'll be continuing with the same paper, but today we'll do question. We have done question number 1 and question number 2 in our previous video, and now we'll start with question number 3. All right. So let's begin with it. Okay. This question is about the preparation of salts. Zinc nitrate is a soluble salt. It is prepared by the reaction of an insoluble carbonate with the dilute acid. All right. So the equation for this reaction is given, and wait a minute. All right, yeah. So the equation is given, and a sample of 4.5 gram of zinc carbonate is added to 50 centimeter cube of 1.3 mole per dm cube nitric acid. Show by calculation. Okay, we have to show that zinc carbonate is in excess. So basically, the most simplest thing is when in for moles questions, especially for these mole calculation questions, if you get stuck like what to do next or how to start the question, the most easiest thing is to take out moles. Okay, well this question is pretty simple, so we can do it in jiffy. Okay, so zinc carbonate is here. This is zinc carbonate. Let me mark it. Yeah, zinc carbonate. Okay, so we have to show that zinc carbonate is in excess. All right. Let me first find out the moles for zinc. Okay, so let me in the periodic table. Yeah, zinc is here 65. Okay, zinc is 65. So for MR we'll do, let me write it MR 65 plus 12 plus 16 into 3. 12 is carbon and 16 into 3 is like 16 is oxygen and 3 oxygen. Okay, so 65 to 12 into 6, sorry, plus 12 plus 16 into 3, 125. So the MR is 125, right? And we have the mass here. Here's the mass. Okay, so by using the formula, moles equals to mass upon MR. Mass is 4.5, MR is 125. So 4.5 divided by 125. This is 0.036 moles of zinc carbon. Okay, so we aren't done yet because they have asked us to show that zinc carbonate is in excess. How can we show that it is in excess? By comparing the moles of nitric acid. So here we are given the volume and the concentration of nitric acid. All right. So we'll do it with another color. So for nitric acid we are doing now. So 1 dmq is to 1000 cm3. Okay. Because most of the time the volume is given in cm cube and the concentration is given in mole per dm cube. So for making it more easy to solve, we can what we can do is this put a cut on dm cube and write 1000 cm cube. So here what we can write is like 1.30 equals to 1000 cm cube. So 50.0 cm cube would be x. Okay. So let me calculate 50 to 1.3 divided by 1000, which is 0.065. X equals to 0.065. Of what? H, nitric acid, HNO3. Alright, so here you might get confused that nitric acid has greater moles than zinc, but here they are asking us to prove that zinc carbonate is an excess. So here is the trick. They are confusing us, okay? So here what we have to do is that basically we can see that first of all, see the ratio. In what ratio are they reacting? Right? The ratio is let me make it a bit smaller so it's easier to do other work. So the ratio zinc, carbonate, and HNO3 are in 1:2 ratio. 1:2. Right. So if one is 0.036, right? 0.036, and so what will we do? One, if you take this value, you take this value, 0.036, we need one in it's in 1:2 ratio. So 0.036, right? So how many moles of HNO3 do we require? If we multiply 0.036 into 2, so it would be 0.072. Calculated that, so 0.072 moles of HNO3 would be required, right? But here what we see, we only have 0.065 moles of HNO3. For reaction, we need 1:2 ratio is present for the 1:2 ratio. Is in the reaction we require 1:2 ratio, and according to that ratio, we require 0.072 moles of HNO3. But according to the data given and after calculating the moles, we get to know that we only have 0.065 moles, which means that nitric acid is the limiting reactant and zinc carbonate is an excess. Hence proved, we have shown it by our calculation that the zinc carbonate is an excess. Okay, so as far as the 1 mark for this, 1 mark for this, 1 mark for this, 3 marks for this, and as far as I believe this is the correct answer. And I guess I find this pretty much easier. And yeah, this kind of working is the simplest. So, okay. Once the reaction has finished, the mixture is filtered. Okay, so here they are asking us that once the reaction has finished, the mixture is filtered. Okay, mixture is filtered, which means that there must be some solid present. Okay, so they're asking that state where the mixture is filtered. So Here we know that, like, so yeah, as zinc carbonate is in excess, so some of it will be, left, will be remaining at the end of the reaction. And as we can see, the state symbol solid. And we also know that carbonates are insoluble. So solid, zinc carbonate solid, which means that we will be filtering out what? We will be filtering out zinc carbon, and the mixture is filtered. So, sorry, to remove the excess zinc carbonate. Yeah. All right, let's move towards the next part. So describe how to make pure dry zinc nitrate crystals from an aqueous solution of zinc nitrate. All right, so it's pretty simple. If you know the steps, so it's quite simple to write. So basically, as it's a soluble salt, and you can't even just, it's not, it's basically dissolved in this solution, so we can't just filter it out or do something else. What we can do is we can perform crystallization process. Here what we will do, we will heat the solution, heat the solution till saturation point. Or you can say crystallization point. Okay. Okay, so when the solution is, heated to saturation point, allow the mixture to cool down, and the crystals will start to grow. Then filter out the crystals. So we filter the crystals and dry the crystals, air, or you want to wash them, so we can use any um, organic solvent, because they won't, as because we can't wash them with water, because as it is soluble salt, so it will get dissolved in it, so we can use organic solvents to wash them. Okay, so that is the point. I haven't written it, so that you don't need to write it. You can just say wash it. All right, so part B is lead chloride is an insoluble salt. It is prepared using a precipitation reaction. So name two aqueous solutions that react to give a precipitate of lead chloride. So aqueous. So the easiest thing is to do, take the nitrate, lead nitrate. Yeah. And another could be for chloride. Lead is here. For chloride, we can take HCl, or let's take HCl, hydrochloric acid, or you could take any other soluble chloride. All right, so next question. Okay, ammonium sulfate is a soluble salt. So one thing to learn is that all ammonium salts, whichever salt, whether it's sulfate, nitrate, or any salt which contains ammonium, is soluble. Okay, it is prepared by the reaction of an alkali and acid. So name that alkali and acid used. Alkali. Okay, so let me think. For acid, my favorite one, sulfuric acid. And for alkali, I could use ammonia. Yeah, ammonia is also used as an alkali. Okay, so now question number page further. Okay. Next question is, this question is about compounds that contain magnesium and nitrogen. Okay. The formula for a nitride ion can be written as, so 15 is the mass number, 7 is the atomic number, and 3 minus is the charge. Complete table 4.1 to show the number of particles in this nitride ion. Number of particles, electrons, all right. So this could be tricky. As we know, 3 negative means if there is a negative sign, so it means that for example, 3 minus here. So this means that 3 more electrons than protons. Whatever the number, and if it's with a negative sign, so we will add the proton number and the number given with the sign, and this that would be the given with the negative sign. You should be very conscious about it, that if there is a negative sign, then there will be 3 more electrons we'll add it. But if it's a positive sign, so what we'll do, we'll subtract it from the proton number, and we'll do it for example, let me give you an example. Here it is 7 3 and it is 3 negative. 3 negative. Let me zoom in. Here it is 3 negative. So 3 negative, I told you that if it's negative, so we'll add it. 7 plus equals to 10. 10 electrons. Right, 10 more. And if it would have been like 3 plus, so what would I have done? It is 7 minus 3 is to 4 electrons. This means it would have been 4 electrons. But if it would have been less. Okay. So yeah, let's just keep it here. I will shift it here. So it becomes more relevant. Okay. Neutrons. We know that if we subtract the bigger number with the smaller one, so we'll get the number of neutrons. So 15 minus 7 would be how much? 15 minus 7 would be around 7, 8. Yeah, 8. Protons, we'll directly write this number 7. Okay. So let's move on to the next question. I hope it's clear to you. It's quite easy, so it should be most probably clear to everyone. Okay, state why the formula for a magnesium ion is Mg2 plus rather than Mg plus or Mg3 plus. Okay, so they are asking us. Now I know. First, this particular with this particular charge, 2 plus, is full outer shell electrons, which means it is stable. So that is why the formula for the ion is Np2 plus. This becomes Np plus is full outer shell electrons. The formula for nitride ion is Alright, this is also quite easy if you grasp the right concept. So here we are given N3 minus, magnesium, and here we had been asked about Mg plus and N3 minus. So what we'll take this charge and write it here, and 2 plus here. So what will it become? It will become Mg3 and 2. And do remember that while writing the formula, we ignore the signs. Mg3 and N2. Okay, so next part is magnesium nitrate is an ionic compound with two physical properties of magnesium. Okay, so ionic compounds are, they are soluble in water and they conduct electricity in aqueous state. So I would write soluble in water and conduct electricity in aqueous state. Or I guess solution. Why to waste time? You can write it in few words. Calculate the percentage of mass of nitrogen and magnesium nitrate. Here is magnesium nitrate. We are given the formula. So let me write it here first. MgNO32. So here they are asking that mass of nitrogen. So and let me first calculate the molecular formula. So molecular, mass. Mg is 24, nitrogen is 14, hopefully. This way, 24, Mg 24, nitrogen 14. So it would be Mr 24 plus 14 into 2 plus 16 into 6. So that would be 24 plus 14 into 2 plus 16 into 6, which would be 148. Okay, this is the total, okay. And nitrogen is just 28. 14 into 2, 28. 28 over 168 into 100. Let me just check. Sorry, here and 148. 8 divided by 148 to 100. 18.9. And as we round it off,